We've all felt it. It is a common frustration for everyone. AI that's either too bold and makes a mess, it can be very frustrating, or too timid and asks for permission at every single click. It's a waste of time. But researchers at Carnegie Mellon just asked a smarter question. What if AI could actually predict when you're about to step in? Enter CalCorpus. This is the first dataset of its kind. A massive dataset capturing thousands of real-world moments, seamlessly, where humans and AI work together, seamlessly and efficiently. This is the foundation for PlowPilot, a new system. An adaptive agent that knows exactly when to lead and when to step aside. It knows its place. The result? A 26% jump in usefulness and efficiency. Not by making the AI smarter, but by making it better, a true teammate. But by making it a better partner in our world. It's the shift from independent autonomy to a new world, to collaborative intelligence, a new era of partnership, the future of how we work. It starts here with a new vision. Let's dive into the details for the topic.
Welcome to The Explainer. Today, we're diving into some really cool research from Carnegie Mellon University that gets to the heart of a major frustration with AI assistants. You know the feeling, right? The big question they ask is, how do we teach an AI to know when it should just do the thing and when it needs to pause and ask for our help? It's all about changing the goal from perfect, hands-off automation to, well, something a lot more like real teamwork. So here's how we're going to break it down. We'll start with that frustrating AI assistant we all know and love, or not so much. Then we'll look at the smarter question the researchers asked, see how they learned from real people, and check out some pretty surprising results. Finally, we'll see a new agent they built and talk about what this all means for the future of AI.
Okay, so let's jump right in with a problem that I'm betting feels super familiar to anyone who's tried to get an AI agent to do anything more complicated than setting a timer.
I mean, we've all been there. You delegate a task to an AI, hoping it's going to save you time. But instead, you end up hitting one of two massive roadblocks that just make you want to grab the keyboard and do it yourself.
Yeah, it's this maddening paradox. On one hand, you get the overly bold AI that just barrels ahead, guesses wrong, and makes a mess. On the other, you've got the overly timid one that's so scared of messing up, it stops and asks you for permission for every single click. Honestly, neither approach is very helpful. So the researchers at Carnegie Mellon took a step back. They realized the issue wasn't just about trying to build a more powerful AI. The real breakthrough came when they decided to ask a totally different and way smarter question. And there it is. This is the key. Instead of aiming for this flawless, hands-off machine, they asked, what if we could build an AI that could just predict when a person is about to jump in and take over? That simple shift completely changes the game. It moves the goalpost from pure autonomy to active collaboration. Now, to answer a question like that, you can't just use old data. You have to see how real people actually behave when they're working with an AI. And that meant they had to go out and build a brand new, one-of-a-kind dataset from scratch. So this is what they came up with. CalCorpus. You can think of it as a super detailed recording of people and an AI trying to get stuff done together on the web. It's the first dataset of its kind because it's specifically designed to capture those exact moments of collaboration, when the human steps in, when they step back, and why.
And just look at the scale of this thing. This wasn't some tiny lab experiment. We're talking 400 real sessions, over 4,000 actions recorded, all meticulously annotated. They got a deep, detailed look at how people really work with these tools. So once they had all this rich data, they started digging in. And they found something really, really interesting about us humans. It turns out when we decide to intervene, it's not random at all. We actually fall into very predictable patterns of behavior.
And this chart breaks it down beautifully. They identified 4 main types of users. You've got your takeover types, who wait till the end and then jump in, the hands-on people, who are constantly co-piloting, the hands-off crowd, who pretty much just trust the AI, and then the collaborative users, who selectively step in early to guide the AI. Everyone has their own style.
Okay, now for the results, because this is where we get a classic David versus Goliath story. They took this new understanding of user types and pitted a small, specialized AI against the biggest models out there.
So first, take a look at a monster model like GPT-4o. Unsurprisingly, it's fantastic at knowing when things are going smoothly and it should stay out of your way. But look at that second bar. It's absolutely terrible at predicting the moments when you actually want to step in. It just misses the cues. But now, look at this. They took a much, much smaller model, Gemma, and fine-tuned it on their special CalCorpus data. And wow, it more than doubled GPT-4o's score.
It was dramatically better at figuring out when a human was about to intervene.
And that leads to this huge takeaway. When your goal is to build a great AI collaborator, it's not about having the biggest model. It's about having high-quality, specialized data that actually understands human behavior. In this fight, nuance totally beats raw power.
So, armed with this amazing insight that predicting human intervention is the secret sauce, the team went and built a whole new agent to put this theory into practice, and they called it PlowPilot. So here's how PlowPilot works, and it's pretty darn smart. First, it predicts those moments where you, the user, are most likely to want to step in. It only prompts you for input at those critical points, and the rest of the time, it just confidently gets the job done. And the result of this new approach? Users rated PlowPilot as over 26% more useful. That is a massive leap in how helpful people found the system to be. But here's the kicker, the most important part of all of this. The core AI doing the actual tasks didn't change at all. It was exactly the same. The only thing they added was that smart module that knew when to ask for help. The AI didn't get smarter at its job. It just got way better at working with the human.
All right, let's zoom out for a minute and really think about the big picture here. Because what this research suggests is a pretty profound shift in how we should be thinking about the future of AI.
This quote from the paper just nails it. The new goal isn't creating a perfect, independent AI that never needs us. The new goal is collaborative intelligence, designing AI partners that are smart enough to know when they're better off with our help.
And that leaves us with this final, really powerful question to chew on. As we build these incredible new technologies, maybe the ultimate prize isn't an AI that can work perfectly without us, but one that can achieve amazing new things with us. Is the goal independence or interdependence? Thanks for watching The Explainer.